We are on lesson 3 of chapter 9, which we're going to solve quadratic equations by graphing. First, we're going to solve quadratic equations, then we're going to find and approximate zeros, then we'll solve a real-world problem. First, what is a quadratic equation? Well, that's an equation that can be written in the standard form of ax squared plus bx plus c equaling 0. And we worked with this a little bit last chapter when we were factoring. For example, when we factored, we were looking for two numbers with a product of positive 5 and a sum of negative 6. And we determined that's negative 1 and negative 5. So you have x minus 1 times x minus 5 equaling 0. And to make that 0, x could either be positive 1 or x could be positive 5. I went through that quickly because we already went through that last chapter. We can also find the zeros of a function by graphing. We can make 0 y, for example, and then whenever we come across the x-axis, which y is 0, that would be our answers. And you notice if we use this same function, just replace the 0 with a y, the x-axis is positive 1 and positive 5, just like our answer with factoring. So we could solve these by graphing and finding the x-intercepts. So let's give that a try. First we have to solve x squared minus 2x equaling 3 by graphing. First we need to rewrite this here. We have x squared minus 2x. Then we need to subtract 3 from both sides, so minus 3 equals 0. Then we can replace this 0 with a y and graph it. So we'd have y equals x squared minus 2x minus 3. Last lesson we were doing the graphing, and the first thing we need to do is find that vertex. To find the x of the vertex, you have to do negative b over 2a. Since b is negative 2, in this case it would be positive 2, and since x is 1, it would be 2 times 1, which would be 2. So our vertex is going to be located at x equals 1. So where's that y going to be? Let's plug that in. 1 squared is 1, minus 2 times 1, which is 2, so that would be negative 1, minus 3, that gives us negative 4. So x being 1, y equals negative 4. So x at 1, y at negative 4. Now we can plot two more points that are less than that. If I solved for x as 0, for example, 0 squared minus 2x would be 0, minus 3 would be negative 3, so 0 and negative 3. And then x at negative 1. Negative 1 squared is positive 1, minus 2 times negative 1, so minus negative 2 would be positive 3, minus 3 is 0, so negative 1 is 0. Now that I've done 2 points, I can graph out the other two on the other side of the axis of symmetry, and there we have it. And it looks like we found the x-axis on both sides here. When x is negative 1, y is 0, which is the x-axis. And when x is positive 3, y is 0. So by graphing it, we figured out that our solution was x equaling negative 1 or x equaling positive 3. Let's solve the next one by graphing. First we'll write this into standard form. Negative x squared plus 2x, now we're going to say minus 1, and that's going to equal 0. Turn this into equation with y. We would have y equals negative x squared plus 2x minus 1. We could find the vertex of x by using this formula, so negative b, so that's negative 2, over 2 times a, which is negative 1, so 2 times negative 1 is also negative 2. Negative 2 divided by negative 2 is positive 1. So the vertex is located at positive 1. What's the y value for the vertex? Let's plug in this positive 1. So 1 squared is 1, negative 1 then, plus 2 is positive 1, minus 1 equals 0. Interesting. The vertex actually equals 0 at positive 1. Just to make sure this isn't an anomaly, let's plot 1 to the left. So let's plot when x equals 0. So negative 0 squared is 0, plus 2 times 0 is 0, minus 1 is negative 1. Then we can reflect that on this side. Since the x squared is negative, that means this is going to be facing down. So you notice with this parabola, something's a little bit different. We had 2 dots on the x-intercept before. Now the vertex is on the x-intercept. And whenever the vertex is on the x-intercept, you're only going to have one answer. And that answer is x equals positive 1. Positive 1 is the only answer that can give you y equals 0. Let's solve this last one. X squared plus 7 equals 4x. Let's subtract the 4x from both sides. We have x squared minus 4x plus 7 equaling 0. Replace the 0 with y, so we have y equaling x squared minus 4x plus 7. Let's find the vertex for x by solving the formula. So that'd be negative b, so negative negative 4 is positive 4, over 2 times a, which is 2 times 1. 4 over 2 equals 2, so the vertex for x equals 2. Plugging that in, 2 squared is 4, minus 4 times 2 is 8, so negative 4, plus 7 is positive 3. So when x is 2, y equals positive 3. Let's plot that out. Here's our vertex. Let's plot it when x equals 1 then. We'd have 1 squared, which is 1, minus 4 times 1, so minus 4, that'd be negative 3, plus 7 is positive 4. So 1 and positive 4. If we reflect that on this side of the axis, you're going to notice something. This parabola is going up because the x squared is positive. Well, that means that there are no x-axes, which means that there's no solution. There's no value for x that can get us to have an answer of 0. And if you think about factoring, this would actually make sense. There are no two numbers that can multiply to 7 and add up to negative 4. It would literally be impossible. Negative 4 and 1 only equal 4. 2 and 2 only equal 4. We can't get all the way up to 7 there, so that's why there is no solution. So now we're being asked to approximate the zeros of f of x equals x squared plus 4x plus 1 to the nearest tenth. So what we need to do is graph, and I imagine that since we need to approximate, it's not going to be a whole number, so we're going to have to make a little bit of a guess. Well, we could find the vertex by doing the vertex formula, negative b over 2a. Positive 4 is our b, so that'd be negative 4 over 2 times 1, so 2. So negative 2 is our vertex for x. So the y value for that would be negative 2 squared, which is positive 4, plus 4 times negative 2 would be negative 8, so negative 4 plus 1 at negative 3. So negative 2 and negative 3. And since I don't like working with these big numbers, I'm going to go to the right and then plot the reflection across the symmetry to the left. So when x is negative 1, that's positive 1 plus negative 4, so negative 3, plus 1, that's negative 2. When x is 0, that's 0 plus 0 plus 1, so positive 1. So I noticed that I actually skipped over the x-axis. So as I plot out these partner ones across the symmetry line here, that one doesn't have an x-axis either. But if I draw these out, I notice that there is an x-axis, it's just not a whole number. So we need to approximate. So the x-axis is somewhere between negative 3 and negative 4, and then negative 1 and 0. For both, I've noticed it's actually closer to negative 4 than negative 3. So if I'm going to try the nearest tenth, I'm going to try negative 3.9, negative 3.8, and negative 3.7, and see if we can figure that out. So I'm actually going to need a calculator to find the answer for these ones here. When x is negative 3.9, how close are we going to be to 0? And whichever one of these is the closest to 0, or if I need to keep going to get closer to 0, that will be the closest answer. So if I plug in negative 3.9 for x and solve that out, that's going to give us an answer of 0.61. So after plugging this in, this is the answer I get. That's pretty close to 0, but let's see if we can get closer. When I plug in negative 3.8 into this equation then, 0.24. So we're getting closer. Is this the closest one? I think we'll know after doing this one here. So if I plug in negative 3.7 into this equation, that's negative 0.11. And we've crossed 0 here, so the next ones are going to keep getting bigger and bigger in the negatives. So which one's closer to 0? And I would say the negative 3.7 is closer to 0. So my x value to the nearest tenth is going to be negative 3.7. And since I see that that's 1.7 away from the vertex on the left, this one's going to be 1.7 from the vertex on the right. So it would be negative 2 for the vertex here plus 1.7. That's going to give us negative 0.3. So my x-intercept is going to be at negative 3.7 and negative 0.3. So that's going to be the answer for this function. So those will be the zeros for this function here, negative 3.7 and negative 0.3. So it says an athlete throws a shot put with an initial velocity of 40 feet per second as shown. Asks us to write an equation that models the height h in feet of the shot put as a function of the time t in seconds after it is thrown. Use the equation to find the time that the shot put is in the air. If we use our vertical motion formula, we have negative 16 times t squared. If we use our vertical motion formula, it would be h equals negative 16 times t squared plus v times t, then plus s. S is the initial height, and I see that the initial height is 6.5 of the ball. The initial velocity, v, is 40 feet per second, so plus 40t plus 6.5. Now we just need to solve h and negative 16t. The ball stops being in the air when the height is 0, when it lands on the ground. So 0 equals negative 16t squared plus 40t plus 6.5. So I can graph it just like I've done before. I have my y equals negative 16t squared plus 40t plus 6.5. And you're probably thinking, oh no, another graph we got to make here. Now I get to show you the fun part, where we actually can use a calculator to solve this. So I press y squared on the top left of my calculator, and I actually could plug in my equation, negative 16t squared, which I'm going to use x instead, plus 40t, or 40x, plus 6.5. And then I could press graph on the top right of my calculator to graph that. So there's my graph. And I'm zoomed a little too far out here, so I'm going to press zoom and go to 0, zoom fit. Press enter. And I can zoom in a little bit so I can see where the x-intercepts are. So to simplify this a little bit, I took a screenshot of my calculator and I pasted it onto here so we can work with that. So what I did is I took my cursor and I moved it over to the x-intercept that was positive, because clearly the time wouldn't be negative. And the closest I can get for y, which was the x-intercept here, which is 0.186 for y, I was at a 2.648 for x, or would it be t in this equation? So the time would be 2.648 or 2.65, we'll say, seconds.